class we'll be looking at the effects of temperature change on equilibrium position of a reaction. For a reversible reaction, which is in equilibrium states, if the temperature of the reaction changes, either the temperature increases or it reduces, the equilibrium position of the reaction will be affected. So that is what this question wants us to answer. Let's quickly go to the question. The question says, for the reaction below, what is the effect of increasing the temperature of the reaction at equilibrium? And the reaction given to us here, it says nitrogen gas plus 3 moles of hydrogen gas produces 2 moles of ammonia gas. Here is the equation for the reaction given to us. And from the equation, from the question, we are told that the enthalpy change of the reaction is equal to minus 92.4 kilojoule. Minus 92.4 kilojoule. That is the enthalpy change. Remember, delta H stands for change in heat, or you call it enthalpy change. Now note this. The effect of change in temperature on equilibrium position depends on the value of enthalpy change, which we call the heat change of the reaction. Now let me quickly summarize this. Note this. When the enthalpy change of the reaction is positive, we say the reaction is endothermic, which simply means heat is absorbed from the surrounding to the system. That means the reaction absorbs heat. But when the enthalpy change of the reaction is negative, it simply means that heat is being evolved, or heat is being given out from the reaction into the surrounding. So, when the enthalpy change is positive, an increase in temperature will favor the forward reaction. But when the enthalpy change is negative, an increase in temperature will favor the backward reaction. How will you be able to remember this always? It's as simple as ABC. Let's look at it this way. If enthalpy change is positive, we say reaction is endothermic, which means the reaction is absorbing heat. Just make this rough assumption. Make this assumption within yourself. Anytime enthalpy change is positive, tell yourself that the product is cold. Or you say, just say that the product is cold. This is just a personal assumption. While the reactant is hot. But when the enthalpy change is negative, tell yourself that the product is hot. Now you can be able to tell, for a product that is hot, what can you do to favor him? Tell yourself, if you are feeling hot, what can I do to favor you? Is it to increase your temperature or to reduce it? We all know that if you are feeling hot, for us to favor you, we need to lower your body temperature. But if you are feeling cold, for us to favor you, all we need to do is to increase your temperature. Take it that way. Though not scientific, but use this guide to answer questions like this. So, let's answer that question straight away. We are being asked, what is the effect of increasing the temperature of this reaction? If this reaction is increased in terms of temperature, if the temperature of the reaction is increased, what will happen to the equilibrium position? That's the question. Remember, the effect of temperature depends on the value of enthalpy change. Now let's get to work. From the enthalpy change given to us, we can see the value is minus 92.4 kilojoule. it simply means that the enthalpy change is a negative value. When the enthalpy change is negative, make this assumption within you, as I said. Tell yourself that the product is in a hot state. It is generating heat. It is in a hot state. Now, what can you do to favor this product? Before we can do that, let's read what the question says. Remember, the question says, what is the effect of increasing the temperature? Now, this enthalpy is negative, which means this product, just focus on the product, forget about the reactant, which means that this product is hot, negative, and temperature is increased. If temperature is increased, will it favor this man? This person, which is the product, is already in a hot state because this is negative. Since it is hot, increasing temperature will not favor him. And whatever that does not favor the product will favor the reactant. Now, an increase in the temperature of this reaction will favor the backward reaction. Why do I say so? Because the enthalpy change is negative, which means an exothermic reaction. So our answer simply means equilibrium position will shift to the backward direction. Remember, it will not favor the product because it is in a hot state. Increasing temperature will not favor someone who is already hot. So since it will not favor the product, it simply means that the reactant will be favored. So our answer will become equilibrium will shift to the left. Either you say to the left or you say to the backward direction. Thank you for watching once again, and do not forget to subscribe to our channel and share to your friends. Remember to hit the like button.